Hello everyone, welcome to the today's session. So in today's session we are going to discuss about answer writing, right, which is what the most important thing as per your mains examination is concerned. So today we are going to discuss about the answer writing, right? So this answer writing is far different than answering the objective questions, that is multiple choice. Yeah. Now voice is audible to all? Yeah. So this answer writing is far different than answering the objective questions, there where you find multiple choice, right? Just merely by remembering the formula, up to somehow you can manage the show, right? In object examination for sure, by knowing the formula or sometimes maybe by luck also, right, we can manage the show. But here, no such scenario. For answering such kind of questions, what we are going to expect in mains examination, first you should need conceptual clarity. So conceptual clarity. So what exactly this conceptual clarity means? So conceptual clarity. Without this, you can't even attempt a single question in mains examination. That is for sure. Without conceptual clarity, you can't attend a single question in mains examination. So please keep that in mind. Okay, please keep that in mind. And as I earlier said that in objective, up to somehow we can manage the show with some basic knowledge and by remembering some important formulae, we can manage the show. But here that is not the scenario. And everyone is comfortable with what I am talking, right? All of you. Yeah. So here in conceptual clarity, first thing we need to understand is theory. Right? So theory corresponding to that particular subject or that particular topic, right? So one should have the knowledge of this theory, and after theory, any formula present in that, maybe derivation, okay, or application of that formula. It means, see, in our civil engineering, not all the formulas are derived. There are some empirical formulas which are based on experience and experiments. Those empirical formulas are mainly based on experiments and experience. So that mainly we find in geotechnical engineering, soil, and even in our code books like IS 800 corresponding to steel and IS 456 corresponding to RCC. Right, IS 1343 corresponding to PSC, pre-stressed concrete structures, right? So likewise, not all the formulas can be derived, but whatever the formulae or you can say provisions that are existing based on theory, you should remember. Okay, you should remember. And obviously based on this formulae, or we need to make use of this formula, that is application, right? Application part. Of course, these formulas, some may be derived, and some other are empirical. But whatever might be the formula, okay, whatever might be the formula, you should understand and ultimately should remember it. But for remembering it, okay, but for remembering any formula, whether it is a derived or empirical, one should feel the subject. It means you should be able to understand what is happening over there. Okay, what are the various terms present in that formula? Okay, what are the various terms present in that formula? Suppose you take one simple formula. What are the subjects that are completed to you? Highway, geotechnical engineering. Okay, let us take a geotechnical engineering as an example. So almost all the topics are completed for you. Okay, now what's the topic that is going on? shear strength. Okay. Suppose let us take shear strength one formula. I'll explain you how to remember it without any by hearting or without any what you can say muck-upping process. Okay, without any by heart. How to remember? Just I'll explain one or two formulae. Shear strength. Generally, we represent shear strength with either tau or S. Okay, whatever it might be. What is the formula for the shear strength? This is the formula. See, no need to remember this formula. The reason, that doesn't mean that you should forget it. Okay, no need to remember means no need to by heart. That is my exact meaning, right? So, all of your graduates, right? It means you have crossed your 8th standard, 9th standard, and then +1, and after that graduation, right? So, I think if I am not wrong, in 8th standard, you have started studying coordinate geometry. Yes or no? Just started studying coordinate geometry. Suppose this is x-axis and this is y-axis. Now there is a line. There is a line passing through origin like this. Now what is the equation of that line? Can you please tell me? Y is equal to perfect. Y is equal to mx. See, hope all of you are graduates, right? So please don't commit these kind of mistakes. Okay. Please don't commit these kind of mistakes. Then God will also not save you. Right? He will also not come under your rescue. Okay, you should have that conceptual clarity. It means from the basics, right? From the 7th standard or 8th standard, whatever you have studied, all those things you should recollect or you should remember. Of course, first you need to recollect. Why? Because you have crossed those phases, right? 8th, are you past 8th, 9th, 10th, all the classes? All of you? Pakka? Then you are taking that it is y is equal to mx plus c. It is y is equal to mx as it is passing through the origin. Right, as it is passing through the origin. And what is this equation? Equation of this line? Here, this equation of line. Y is equal to c, constant. Of course, c means constant. Yes, correct. And here I will draw. Now, what is this equation? What is this equation? Y is equal to mx plus c, isn't it? These three are only the basic for shear strength formulae what you study. These three graphs are these three equations what you have studied in 8th standard, if I am not wrong. If I am not wrong, what you have studied in 8th standard, these three equations are basic or foundation for shear strength formula. This one. It means in shear strength, I think you might have studied Mohr circle. Right, that Mohr circle is plotted in between normal stress on x-axis and shear stress on y-axis, isn't it? And after drawing the Mohr circle, we draw the common tangent, which is called as Morse Coulomb envelope failure envelope. Okay, Morse Coulomb failure envelope. So based on that Morse Coulomb failure envelope, we write the we write this particular formula for shear strength, isn't it? So now you see this concept I'll compare with that. And shear strength, you might have studied the types of soils also. What are the types of soils you have studied over there? See soil. See, soil is having so many classifications. Based on the size, the classification is fine grained and coarse grained. Right? Based on some plasticity characters, there is another classification. So all those things you study in soil classification, leave it. But here in shear strength also there is the one soil classification. That is C soil, Phi soil, and C5 soil. So how this classification has made? Based on shear characteristics of a soil. It means any soil will contain strength, or any soil will possess strength mainly by 3 parameters. What are those 3 parameters? Friction, of course, cohesion, friction, interlocking, and cohesion and adhesion. Right? So if particle size reduces, then surface phenomena predominates and the contact will be very less. Then there is no friction. So when the friction will generate, you please tell me. When the friction will generate, when there is a contact area. See, I'm walking on this floor. How I am able to walk on this floor? Because there exists a contact between my foot and floor. Because of that contact, friction will develop. That is why I am able to walk, or else I will simply slide and fall down. So for the friction to develop, there should be contact area. So for that contact area to develop, size should be more. So that more size we observe in sand and gravel, but not in clay. Therefore, mainly coarse grained soils like dense sand, sand and gravel will exhibit shear strength by friction. Isn't it? Whereas coming to the clay particles. So for clay particles, size reduces, therefore surface phenomena predominates. That is a development of charge over the surface. Because of that, attractive forces will develop. That is known as cohesion and adhesion. Okay, that is known as cohesion and adhesion. And interlocking, it means if size further reduces, like angular particles, you might have studied. So interlocking will be like this. So why? Because there will be some projections of the particles on the surface. Suppose this is the surface, there will be a projection like this. And for another particle, there will be a projection like this, then interlocking. Like this, the interlocking. So how do we measure this interlocking, friction and attractive forces? Based on these parameters, C5. And based on that, there is a classification. So like this, you need to understand the subject, or like this, you need to analyze the subject. Right? So now, these 3 types of soils. Okay, these 3 types of soils. Of course, if I go into further details, then we are having some different stages of testing and different dryness conditions. Okay, that is not our point of discussion at this point. Why? Because the shear strength alone will take not less than 4 to 8 hours. If we discuss the total experiments and total conditions and everything, so that is not our main point of discussion. But what I am trying to tell you is how to remember the formulae, or how to see the subject, or how to feel the subject. So if you understand the subject in practical manner, or in other words, if you visualize the subject, what is happening in the soil, if you are able to feel, or if you are able to visualize what is happening inside the soil, then no need to by heart, right? Obviously, you will remember for more time, at least up to the examination. Till the end of the examination, you will remember it. That is what required, right? So C5 and C5 soil, right? Now, this C soil, as the name indicates, here phi is 0, isn't it? And this is phi soil, obviously C is 0. And here C5 soil, both are existing. Then, if you draw the more Coulomb failure envelope for this soil, then it will be like this. Therefore, shear strength is simply S is equal to C. And we determine that C by making use of various experiments like direct shear test, triaxial shear test, vane shear test, and unconfined compressive shear test. Isn't it? But out of all these, triaxial test is the most versatile. Why it is most versatile? Every dryness condition, what we require, can be achieved in the triaxial test. And even test can be done perfectly in 2 stages, confining stage and shear stage. And all the dryness conditions like UU, CU, CD, all the dryness conditions can be achieved in triaxial test. Isn't it? So based on that, we can derive phi C, of course. Those are called as shear parameters. So whatever the experiments we are going to carry out, all the experiments are meant to determine shear parameters only. And based on the shear parameters, we can determine the shear strength of a soil corresponding to its type. Means all the soils don't possess same type of properties, shear properties. Some soils will have some properties only. And even if you see sea soil, okay, sea soil. So most best example of sea soil is clay. But see, the very same clay behaves in one manner in undried condition and in different manner in dried condition. In undried condition, it exhibits cohesion, whereas in dried condition, it exhibits friction. So we need to be very careful. See, why this topic or why soil is most complicated? Because so many aspects you need to consider. Let me say one small example. If route to your home to infinity is straight, then easily you will go. Yes or no? In when you are sleepy also, you can go very easily, right? Whereas if so many turns, U-turns, it means if full route is of complicated, it means it is not straight. So many turns are there, U-turns are there. You need to climb one what you can say steep slope, like that the route is there. Then you will feel complicated or not. But you know the destination. But the route is not straight, then you will feel somewhat difficult. The same case with soil also. Same case with soil also. So it is not straight away. Okay, it is not straight. So many U-turns, so many turns, right turn, left turn, U-turn. So many turns are there. And even steep slopes will also there. That is the reason you feel somewhat complicated with this subject, but nothing like that. Once provided you are clear with all the aspects, then it is very clear. But it requires time. It requires time, and you need to study it and understand it more and more. Means ultimately you need to spend time. Yes or no? When the route is not straight, then obviously you need to spend more time to reach the destination. Yes or no? The same here, that's it. So you should have that patience, right? You should have the patience, that interest and everything. Ultimately, you are the one who need to reach to your target, right? We are like, what you can say, guides. Means to show you the right path, that's it. And to shed a light on your path. Okay, to show the path and to show a light on the path, so that you will feel little comfortable, that's it. That is the part of ours, nothing more than that. Don't think that merely joining in institute, not only this, any institute, will not serve the purpose. You are the one who has to reach to your target ultimately. Right? We are like, as I said, we are like guides. Right? We teach you and we guide you in a right direction. And wherever you feel demotivated, there we motivate. That's it. That is our main role. Okay. Now coming back to this. So this C we can determine. This is the shear strength. So S is equal to C. This is like Y is equal to C or not? Now here C is 0. Then what should be the graph? Here on X-axis represent normal stress and on Y-axis represent shear stress. So what is the equation? Y is equal to mx. Now what is Y here? Tau. M is nothing but slope, tan theta generally, but here the theta is phi. So now x is sigma n, so tan phi, this is the formula. Now C phi soil, for this soil, if we see the graph, this is the graph. Now what is this equation? Y is equal to mx plus c. So Y is tau here, M is tan phi, right? Tan phi, and x is sigma n. So sigma n tan phi plus c. No need to by heart. I think now this you remember this formula lifetime, for lifetime. Why? Because the very same formulas you have studied in your 8th standard in mathematics, coordinate geometry. But the thing is, you are unable to interlink it. You are unable to interlink it. See, engineering subject, whatever the subject you study in this engineering is not a new to you. It is just an extension. Okay, it is just an extension to the concepts and subjects what you have studied in your elementary level, and after that secondary level, and in your +1 and +2. So what happened generally is there is a missing link between the things what you have studied in your school and +1 and +2 and in graduation. There is a missing link. It means you have studied up to here, maybe up to this table level, maybe in surveying you study that, RLs and everything. So this is the level you have studied in your plus 1 and plus 2 level, up to plus 1 and plus 2 level, this is the level you have studied. Now, in graduation, you study from here. Okay, in graduation, you study from this level. Now, this is the gap link. So, this is what the missing. Okay, this is what the missing. Because of that, you think all these subjects are new to you. And you will feel obviously bored. Right, obviously why? Because subject is always boring, right? Subject is always boring. Why it is boring? Because you are unable to see it or visualize it. Suppose you take a movie. You remember it for maybe lifetime or more time. Sometimes you yourself feel as a lead actor or actresses, right? Why? You are going to feel it. Why? Because everything is happening in front of your eyes, so you feel it for sure. The very same thing if you apply for the subject, then definitely you will start enjoying the subject. As I told you, there is a missing link. If there is a bridge between that link or for that gap, then obviously you enjoy the subject. You start feeling it and you will obviously find it interesting and ultimately you enjoy the subject. That is what the point. So see how simple it is. Not only this, whatever the concept, and I think in the very same topic, one master formula is there. Sigma 1 is equal to sigma 3 tan square theta c plus 2c tan theta c. That formula also we can derive from simple mathematics and hypotenuse, Pythagoras theorem. I think all of you are aware of what is the formula for sin theta, what is the formula for tan theta, and what is the Pythagoras theorem, right? And some trigonometric relations, sin 2 theta, cos 2 theta. With this we can derive that formula. Nothing new. But in what is the main difference? That is what I am trying to tell. So in your elementary level, 8th or 9th standard, you don't know the application of the formula. You simply study sin 2 theta means 2 sin theta cos theta. And cos 2 theta means you simply study cos square theta minus sin square theta. Or cos sin theta means opposite side by hypotenuse. Cos theta means adjacent side by hypotenuse. That is what you study, that's it. But you don't know the application. Pythagoras, everything you study, but you don't know the application. But here, we make use of those concepts to the practical scenarios. So, properties of circle also well aware to you, right? That is more circle. But your name is more because given by the more. And of course, it is having some significance also, which is what you study in strength of materials actually. And and one more point you please remember, if you are studying one subject means please don't confine your what you can say imagination and visualization to that subject itself. Please don't confine, interlink it. As I told you, this total more circle concept is having its root to strength of materials. From the strength of materials we have picked it and we are making use for studying the shear strength. You take the same soil, I think you might have studied seepage and what is that, permeability, etc., right? Effective stress. Now in that seepage, what is meant by seepage? Flowing of the water. Therefore, fluid mechanics concepts we make use. Heads, hydraulic head, datum head, pressure head. Have you studied it? That's it. That is from fluid mechanics, not from soil. We make use those concepts in soil. Likewise, every subject is interrelated. Okay, interlocking will be there. Every subject. So try to interlink the subjects. So all these things, as I told you, try to visualize the subject by knowing what is happening exactly there in the subject and try to interlink it. So all these factors ultimately make you to feel the subject, and if you start feeling the subject, then obviously you feel it interested, then you start enjoying it, provided you remember it for more time. As I told you, at least for the completion of the examination, isn't it? That is what the point to be noted. Okay, that is what the point to be noted. So likewise, every formula will have some basic background. Background means whatever you studied in your fundamental levels. Okay, whatever you studied in your elementary level, that is what the shear strength. I think, hope you will not forget this formula forever, right? Like this, every formula will have some background. So that is what I am trying to tell here. That is what I am trying to explain here. So theory and theory related formula and its application. That is what I am trying to tell here. For this I have taken that example, that's it. Okay, in some cases, like you take building materials. So in building materials, there is only less formulas. Only in concrete, we are having some formula like mixed design. Okay, in mixed design, we are having some formula. Other than that, no formulas are there. So theory and its application. In some subjects, theoretical subjects, mainly like building materials. Okay, in cement, concrete, timbers, brick and stone. So no need of this formula as well. This step is not present over there. Of course, it is present, but very less frequent. But generally, if you see, these are the things that are present in any subject. So first, theory, learn the theory. Okay, understand it. Try to visualize it. Okay, try to visualize it. And later, formulas present in that theory. Like you take in strength of materials, suppose there is a famous or popular formula for pure bending. That is, I think all of you are familiar of it. What is it? M by I. Yes, M by I is equal to sigma by Y is equal to E by R. So that formula we can derive based on pure bending theory. It means suppose this is a beam, simply supported beam. At times we apply a couple like this. For this case, we have derived it. So that is the theory over there. Based on that theory, we have derived that formula M by I F by Y or sigma, whatever it may be, E by R. Just here I'm giving you a few examples. Why? Because in this session of 1 or 2 hours, we can't discuss all the subject and all the formulas and theories present in our civil engineering. Why? Because this civil engineering basically we study for 4 years, right? That 4-year subject here we are going to consolidate in a span of 2 months, 3 months or 4 months. So that 2 months or 4 months course, I can't further consolidate in 1 to 2 hours, right? That is the reason just I'm giving a few examples. But for every subject and every topic in the subject and every theory in that topic will have the same thing. Understanding the theory and any formula present in it, that formula may be either derived or empirical. As I told you previously, soil, that is not derived formula, that is empirical formula. Even though it is empirical formula, but it is having a concept, basic, isn't it? That is what I explained you. That is not a derived formula. Shear strength S is equal to sigma and tan phi plus C is not a derived formula. It is empirical formula. But still it is having a background or basic. Even though, as I told you, empirical formula means it is based on experiments and experience. Okay, so that experience may differ from person to person. So I am having one experience with subject and you are having another experience with subject, right? So that is why it is called as empirical, means not universal. Whereas derived as universal. If you apply the same logic, same concept and same aspects, definitely you will get the same formula. Even I too get the same formula. Everyone will get the same formula. That is what the derived means. It is which is having universal approval. Okay, right. So that is what the form and application. Clear all of you? These things you need to keep in mind. Okay, these things you need to keep in mind. And one more thing, we at Infinity are going to start this question practicing session exclusively. I think your exam is on October 14th, right? So time is very less. So what are the subjects that may done? Okay, that will run parallelly. But along with that, we are planning to launch only question practice session, which myself will frame mostly the questions and that course, right? So we are doing that so that you will benefit more and at least you are able to answer the required questions. Okay, required question. Why? Because see, if it is new to you, for everyone the same scenario, isn't it? The only thing that matters is your determination and sincerity. How sincere you are. See, everyone will like you only, right? See, don't think that some are very intelligent and talented. Nothing like that. Here only hard work matters and everyone will be like you only. The only thing that makes the difference is how hard work enough you are in this 2 month span or 3 month span. So July, August, September and maybe 3.5 months are there. Or not 4 months exactly, 3.5 months are there. So how hard work enough you are, how determined you are, will finally decides your result. That's it. Nothing more than that. This time is very precious and crucial to you. So for that we are planning that question practice session. Okay, for that we are practicing a 1 month exclusively question practice session. Right, 1 month exclusively question practice session. So here we are going to take a question such that one question will cover almost 1 to 2 topics in a single subject. It means a total subject can be covered in not less than 10 questions. Then think how the questions will going to be framed. In total 10 or maybe required if a subject is lengthy like soil or maybe structure, toss and essay, not mainly essay, toss. So there were more concepts and formulas are there. Sometimes 10 questions may not be sufficient. So there will increase the number of questions. But mainly in 10 questions we are going to cover all the topics. Maybe in that 10 questions also some sub questions will also there, right? So mainly we are planning to cover that. Okay, we are planning to do that and of course we'll do it. No worry, no issue. So that you please leave it to us. We'll take care of it. Clear all of you? That is a point. So these things you need to bear in your mind. Once again I repeat, merely remembering the formulas, you can't run the show here. Okay, if you remember with formula, then again you'll come back with the same formula. Nothing from the examination hall. With the formula you will go and in between you come with the formulas. That's it. No answer, nothing. You can't do in examination hall. So please try to keep these things in mind. Whatever the subject you start studying, immediately after the completion. So as of now, I think you are not having any questions to practice. But of course, see, nowadays everything is on your fingertips, right? Everything is on your palm, in your hand. So try to search about the questions for a time being. Of course, we provide it, don't worry. But as the time constraint is there, so before that you try to start see some questions, previous year questions, because MPSC is descriptive till 2011, right? After that, the pattern has changed to objective. So previously MPS was descriptive examination, right? But later it was changed. So in I think some in internet sources you may get those some of the questions, not all the questions, but some of the questions you may find are better solve engineering services previous year questions, or you can say SSC J.EE previous year questions. These exams are descriptive examinations, right? If still time is there, you can solve IAS and IFS previous year questions from civil engineering. So lot many sources are there. If you are really serious and dedicated towards your goal, then lot many sources are there. See, for MPSC, for UPSC or for SSC, the syllabus is civil engineering, yes or no? Right? So for MPSC it is civil and for UPSC it is not mechanical for us, right? For us it is all everywhere civil. In civil, everywhere strength of materials. In civil, everywhere shear strength. The same formula. But difficulty of the questions may vary. Sometimes it may be straight away or easy, or sometimes it may be lengthy and sometimes tough. But the same topic and same concept. That is why I am telling you application. This is the main crucial thing. Whether the question is easy or lengthy, or you can say tough, will be decided based on your application abilities. More or less, those who have joined the any institute or those who have started studying, no doubt they will learn theory and formulas in that. But only thing that lacks is application. Obviously, that will decide whether the question is easy, lengthy or tough. So every thing in the question solving directly related to this application. But you can go to this application after knowing the theory and formulas in it, isn't it? This is what the conceptual clarity exactly means. Okay, this is what the conceptual clarity exactly means. Now coming to the questions, mainly we are having two types of questions, isn't it? What are the two types of questions? So types of questions. Types of questions and their evolution. So evaluation means allotting the marks or correction. Okay, evaluation means correction, right? How many marks we may get for those type of questions. So generally there are two types of questions. I think you are aware of it. What are those two types of questions? One is theoretical and another is numerical, right? You are aware of it. Theoretical and numerical, right? So these are the two types of questions. Now coming to the theoretical question, how well you may write or how effectively you may present your total concepts and knowledge you are having, but still you are not going to get full marks here. Even though you are Shakespeare, but still you don't get full marks here. Definitely. So that is what the general thing related to this theoretical questions. But still you need to attempt it. But why? Because question paper will consist of mixed thing. Question paper will consist of both theoretical and numerical. It is the perfect combination between those two. Hence you need to attempt the theoretical and numerical. But what I am trying to tell here is, if there is a case where you need to choose between theoretical and numerical, then which is better to you? Numerical, provided you should have well practice and you should aware of that question. You should aware of that question. Without that, you can't attempt the numerical, right? But in comparison, this is difficult. In comparison, no doubt, numerical is difficult. But your approach means your total formulas that are required to solve the question are correct, and your procedure is correct, and final answer is correct. Then you will get full 100% marks. But here you will get 80 to 90, and in some cases 95. 95 is a rare case, percent marks. So if your answer is correct, then here you will get 80 to 95% marks. But here 100% marks. That is why, provided you are having any choice between or any chance to select between theoretical and numerical, then what is the best to choose? Numerical. Because here 100% marks you can get, provided your answer is correct. Total formula and total approach and everything is correct, and final answer is also matching with the correct answer, then you will get 100% marks, full out of full. But here that is not the scenario. Okay, that is what not scenario. But this can possible, or you can do that judgment only after having a good knowledge and well practiced. After a good practice and a knowledge, you can do this, or else nothing. Simply blank faces like you in examination also. So you should have that, right? You should have that good knowledge and practice. Knowledge is not merely sufficient. Along with knowledge, so if knowledge plays a 1 step in answer writing, then practice plays 10 steps or remaining 9 steps. So knowledge, practice, 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 practice. That's it. Nothing more than that. Nothing more than that. As you are aware of that quotation also, practice makes man perfect. Don't ask me why not women. Of course, it is general statement. It included humans. Practice makes, basically it should be like practice makes humans perfect. That should be the quotation, of course. But maybe I don't know the background, leave it. That is not the topic. So, theoretical. Clear all of you? And one more thing, coming to the evaluation, till date, no one knows how the marks are allotted to this descriptive questions. Why? Because for the past 40 to 50 years, UPSC is conducting descriptive examination like engineering services, civil services, and etc. But till date, no one has that clarity how we are going to get the marks exactly. But based on the experience and my experience, see, basically I have appeared for engineering services twice. And of course, I have gone through the interview also. So based on my experience and even based on the experiences what I got from my friends and colleagues or some of the students of mine, so I can analyze it. I can analyze that. Coming to the numerical, our formula is correct. Okay, formulas are correct and approach is also correct. See, this is based on experience. This is not exact. This is like exit polls. It is not an exact result, right? Based on the experience I am sharing with you. So if approach is correct and final answer is not matching, not correct. So final answer is not matching with the correct answer. Okay, final answer what you have got is not matching with the correct answer. Then suppose the question is for 10 marks. Chances are there for you to get 5 to 7 or sometimes 5 to 8 marks out of 10. Chances are there. Chances are there. So why 5 to 8? Why? Because no one knows how exactly the examiner is going to allot the marks. No one knows. But one thing is for sure, he will not cut you the total marks, provided your formula and approach is correct. Somewhere in the calculation you have done the mistake and final answer is not matching with the correct answer. Then total marks definitely are not going to be cut. Definitely will get the marks. So more than half only you are going to get. That is why I have given here 5 to 8 marks. Sometimes if examiner is in good mood and of course he is having empathy towards the students or candidates, then he may give 9 marks also. Depends, but not full marks. That is for sure. He will not give full marks and he will not cut full marks. That is for sure. Between the gap is there. That gap no one knows. Like you take in RCC. So there are so many provisions. Suppose you take cover. For slab the minimum cover is 20 mm. It means you can provide up to 100 mm also. Minimum should be 20 mm. There is no upper limit. So as per our wish we can do it the same. Here also full marks are not going to be cut and full marks are not going to be allotted in between. So based on the experience 5 to 8 marks we are going to get. But there is a one more condition which occurs rarely. Formula is wrong, approach is wrong, but final answer is correct. Sometimes maybe agar kismat acha hai to hota hai, right? But still 0 marks. Okay, 0 marks. It's not home, okay? 0 marks. 0 marks right away. This is the case. So that is why I'm telling you, final answer matters. But formula and approach. Approach means that application. Using how to make use of that formula. So that should be correct and formula to be also correct. Then you will get, as I told you, a good number of marks, not full marks. But as I told you here, theoretical also, don't write these theoretical questions like in your semester examination. Straight away they will cut it. There should be a bullet points. It means for answering this theoretical question, basically, you need to remember, okay, you need to remember some points here. Introduction, okay, introduction, and then explanation, and then conclusion. These are the 3 things that has to be maintained for every theoretical question, but not all the time. But this is the framework. Here for numerical question, formula, approach and final answer. And of course, initially you need to write the given information. But this given information will not have any marks, okay? Just to tell the examiner that you are aware of the informations what are given in the question. Just to tell the examiner, that's it. For that you need to write given. But like in our semester, for given also 2 marks will be there, right? And for filling the mark sheet, additional papers or additional sheets, we are having some marks of 2 marks. That is not valid in public service commissions. Okay, that is not valid. So don't follow that strategy. Straight away you will get 0 marks. Right. So given, first you need to write it so that examiner will come to know that you have gone through the total question and you are well aware with the given information. So write it and then start the formula. Write the formula by writing we know that. But because some formulas in the examination, as per the question, we can't derive it. Of course, they might have some background and some derivation. But in that question, derivation is not required. So you write we know that and write the formula. And substitute the given information in that formula. And sometimes not only one formula, some 2 to 3 formulas we need to make use. That is what the application and approach means. Okay, that is what the application and approach means. And finally, by carrying out the calculation, we get the final answer. Somewhere here, as I told you, we made a calculation error. So final answer is not matching. But still, formula and approach is correct means we will get the answer. This is how to write the numerical question. This is the framework for numerical question. Whereas for theoretical question, this is the framework. Introduction. So this introduction includes definition. Maybe some definitions will be there. Definitions or some any other bullet points related to that particular topic, and then explanation, and then conclusion. But see, sometimes theoretical questions are for 2 marks or 4 marks. In that, we can skip introduction or conclusion, we can skip. Right? Why? Because for 4 marks, no need to elaborate more. Simply, we introduce it and we leave it. But sometimes, see, means as MPSC, okay, but for the past 10 to 12 years, there has been no descriptive pattern. So, based on the UPSC experience, I am telling you, the very same question can be asked for 5 marks and 20 marks in UPSC. Same question can be asked for 5 marks and 20 marks. That is what UPSC means. Now, in MPSC also, chances are there for the trend, because in MPSC in mains objective pattern, I have seen so many questions directly picked from engineering services prelims. Right? Previously, it was the objective examination, right? So, in that previous year papers, if you take engineering services prelims papers and MPSC mains objective papers. So, most, not all questions, but some questions are directly picked from it. Like some questions, what I remember in structural analysis in SCA. Matrix, some questions, previous questions are there. Those are directly picked from engineering services prelims. Not only from SCA, even TOS, some questions from soil, like that. For every subject, there are some questions, but I don't remember exactly, but I've analyzed it. So, based on that, based on the trend I'm telling you, here MPSC, in mains also, they may follow UPSC engineering services mains or civil services mains or IFS mains. Chances are there based on the previous trends. Always remember one point. No one will give you the exact thing, exact analysis. No one will give you the exact analysis. I told you, like, if you are aware with the elections, before elections itself, some surveys will be done, right? They are called as exit polls. In the very same way, here we are going to do you. They are not exact. Sometimes the total exit polls may gone wrong. Yes or no? Sometimes. But sometimes more or less the exit polls are correct. Not exactly, but correct. So, these don't take it for granted. That is what I want to share with you. Don't take it for granted. But more chances are there because it is based on the past experience. Based on the past 10-20 years experience or trends. Based on the past 10-20 years trend, here we are sharing with you. Like you take hydrology, of course hydrology is not completed with to you, but still you take a hydrology. So to forecast the peak flood, what we will do? We will take the past 20 or 30 years or 50 years data. The same year also. We are taking 10-20 years data, and with that here we are analyzing. That's it. That is not exact. But more chances are there for it to become true. So please try to sense the difference. Being a technical or professional personality, so try to sense the difference. Clear, all of you? So as I told you, the same question can be asked for 5 marks or 20 marks. Sometimes depends. So if it is for 20 marks, then this structure should be done. This framework you should follow. But if it is for 5 marks or 4 marks, then simply introduce it, definition and some related things, and close it. Or if the space is given, then just explain it. That's it. Explain it briefly, not elaborately. Suppose this I'll explain with one question. Cement. I think all of you are aware of the cement, right? Cement. Suppose there is a question asking you to write about various types of cements. Okay, different types of cements. So this is the question. Different types of cements, right? Different types of cements. Explain about different types of cements. If this question is given for 5 marks, then what you should write? No need of elaborating or no need of doing anything. So what are the different types of cements are there? First, rapid hardening cement. Okay, rapid hardening cement, and write elaborately about it. Okay, write elaborately about it. And then extra rapid hardening cement, and elaborate about briefly, not elaboration, brief about it. Okay, why it is used. So basically in rapid hardening cement, here we are going to increase C3S more. Okay, here we are going to increase C3S more, right? So for extra rapid hardening cement, along with this we are going to add CaCl2. So just brief it, no need of going into details, right? No need of going into details. And then rapid hardening, extra rapid hardening, quick setting. Okay, quick setting cement, right? QSC. Why to elaborate it? Quick setting cement. So in quick setting cement, C3A is more. C3A is more and gypsum is less. Gypsum content is less. So like this you need to elaborate it. Okay, sorry, not elaboration, brief it. Why? Because it is 5 marks. And then low heat cement. And you write where we are going to use it. So generally this is used for road repairs. Okay, repair works. Where farm work has to be removed quickly. Okay, and here the same functions, but even in cold climate we can make use of it. Cold weather. Now quick setting in water retaining structures, we can use it. So these are the briefing. Okay, these are the and low heat cement. So in low heat cement, C2S is more, and C3S and C3A is less. Mainly we use in mass concreting, like in dams and raft foundation, right? And then after low heat cement, rapid hardening, extra rapid hardening, quick setting, low heat, and then that is totally different. Okay, see here what I'm trying to tell here I'm giving you the cements which can be obtained by varying the constants of ordinary Portland cement. See, basically cement is of OPC, right? Ordinary Portland cement. So that ordinary Portland cement consists of box compound C3S, C2S, C3A and C4AF, right? By varying these constants, these are the different types of cements we are going to get. Whereas as we are saying PPC, or you can say Portland slag cement or high alumina cement, those are the mainly types of cements where we can change the total constraints of the cement. Is it clear? So that is how to remember the things. Then even in this theoretical subject also, you don't feel difficult or you don't feel to remember more and more. These are rapid hardening, extra rapid hardening, quick setting, low heat. All these are the cements derived. All these are the cements derived by varying the constants of ordinary Portland cement. So if you study clearly about ordinary Portland cement and the various components present in it and function of various components, then easily you remember it. In that way I remember it. See, currently I am not having any book with me, but I remember it. Because I know that total constants and their function. Simply I written this. That's it. Now as we are saying, one more cement is there, that is pozzolana. So basically what are pozzolanas? So pozzolanas are siliceous material. They themselves has no cementitious property, but they exhibit cementitious property in the presence of free lime. Right, in presence of free lime. So if you see the hydration reaction of the cement, we are going to get CHS gel, tobalamerite plus CaOH twice. Actually this is andesite. Now this pozzolana material react with that andesite one and again it forms CHS gel. So in that way we are going to get pozzolanas. We make use of it. So what are the examples of pozzolana? Fly ash. So many pozzolanas are there. Fly ash, GGBS, ground granulated blast furnace slag, and metacoin. So many are rice husk. So many are there. So based on that we are having PPC, Portland pozzolana cement, and then slag cement, Portland slag cement. One more cement is there, I forget from the this one from OPC, that is sulfate resistant cement. So that is sulfate resistant cement. In this, we decrease C3A sulfate resistant cement. Actually, this total 5 are the cements derived from OPC. Next, PPC, PSC, and then high alumina cement. Just simply write about those names and brief it. 5 marks you are going to get. But if the same question is given for 20 marks, then how to write? You need to start the history of cement. Means introduction. So cement. So how to write it? Cement. So cement is basically made from 2 categories of compound. What are those? Calcareous, argillaceous. Okay, calcareous and argillaceous. Now, in this calcareous, main compound what we are going to get is lime. Of course, so many other compounds are there, but major is lime. And in this argillaceous, main compound what we are going to get is silica, alumina. Okay, silica, alumina, and some impurities like alkalis, and then SO3, and of course here MgO is present here, and here also MgO is present. Okay, these are the major constituents. So to remember the constituents of cement, you please remember this code, L psi mass. You remember this? So L stands for lime, S stands for silica, A stands for alumina, I stands for iron oxide. Iron oxide. I stands for iron oxide, right? Iron oxide. M stands for magnesia, A stands for alkali, and S stands for sulfur trioxide. So in the same order. So generally lime present in 60 to 65%. And next silica, and next alumina, next iron oxide. So this is what first you need to write. This is how the cement is going to be manufactured. So by making use of these compounds, we are going to get a clinker in a rotary kilns. Now that clinker we are going to grind it to a fine particles. During that grinding we add gypsum. Okay, during that grinding we get 2 to 3% of gypsum. Then finally we will get the cement. Now in that manufactured cement 4 compounds are present. Those are called as Boak's compound. So now what are those Boak's compound? Directly I am writing C3S, that is tricalcium silicate. C2S, dicalcium silicate. C3A, tricalcium aluminate. C4AF, tetracalcium aluminoferrate. So briefly we need to write about all the constants and their properties, and then we need to come to the different types of cements. If the very same question is asked for 20 marks, chances are there. You don't think that is a 5 marks question, 20 marks question also. Or sometimes they may ask you how the workability of concrete can be affected. First, if the same question is given for 5 marks, then you write just the parameters. But if the same question is given for 20 marks, now this question is given in recently concluded engineering services examination for 20 marks. Then you should write what is workability and all the factors affecting workability, and you need to explain it. So chances are there. So for that you should have that conceptual clarity. Without that conceptual clarity, you can't do it. And that too, if you don't understand the subject or if you don't feel the subject, then you need to remember and everything by hearting. Okay, by hearting, that is not possible. For by hearting, you can remember for a very short span, maybe for 1 day, 2 days, or at most 1 week or 10 days. That's it. Not more than that. Obviously, you are going to forget it because subject is more volatile in nature. Easily it will evaporate from our brain. Okay, easily it will evaporate from our brain. So, like this you need to remember. So, in that is what I am trying to tell. In question solving session, so this is how we are going to discuss. We are going to target each and everything. Whether it is a small topic or big topic. But wherever that logic or that particular concept is there, that we are going to elaborate it in detail. Okay, that we are going to elaborate in detail. This is how the theoretical question has to be answered, isn't it? Clear, all of you? That framework you should remember. But as I told you, that is not valid for all the questions. It depends upon the marks also, marks allotted to that question. But that framework should be there. As I told you, if I was able, if I was supposed to answer this question for 5 marks, this is how I answer. But if the very same question has to be answered for 20 marks, then this is how we need to answer. Total. This total background, explaining about all the functions and properties of box compounds and their proportion present in the cement, and then going for the different types of cements. And then going for different types of cements. Clear, all of you? This is how to answer theoretical question. Okay, this is how to answer theoretical question. And of course, I explained you how to answer numerical question also. Just I'll take one question so that you'll understand how exactly we need to answer. Okay, how exactly we need to answer. With that, I'm going to conclude this session, today's this answer writing session. So see the question, of course, it is from strength of materials. I think it is not done to you in this course, but still you are having some knowledge and required things I'll explain, don't worry. Once you please go through this question, is it clear to you, all of you? And even online students, sorry, I forgot about the online students. Okay, let me see what's going over there. Okay, meanwhile, you please go through this question. Roshan, sir, solve any one numerical. That is what I'm doing here. Okay, generally you people are in a hurry mode, right? Don't worry. Please leave that hurry. I'll take care. See, basically I don't know Marathi, so English I am very comfortable, and you can text your message in Hindi as well. But Marathi, no, I don't know. For Marathi, you need to teach me, right? So any other doubts from online students so far? So Arshita, so session has started around 10:40 something. Around that time session has started. So if you have any doubts, you can please ask, both online and offline, both. Okay, once go through this question. And one more thing I want to know. See, basically nowadays there is some issue with students in Maharashtra or students from North. Why? Because they are expecting their own language or their mother tongue. So are you clear with what I explained so far? Are you clear with English, all of you? Akka? Online students, are you clear with what I have explained so far? So from technical point of view, from subject point of view, nothing I have explained so far. Just here I am making you to familiar with this answer writing, that's it. So in that meanwhile, wherever it is required, I have taken some examples of the subject, some formulae and some theoretical part. But other than that, nothing subject or technical as discussed here, right? So in this general thing, are you clear, all of you? Okay. So gone through this question? Reco. They're saying that echo is good. Echo is there. Now the student is saying echo is there. Voice echo or right? Is it clear? So basically this question is related to the temperature stresses topic in strength of material. And that too, this is of basic level. Okay, temperature stresses topic will have so many subtopics, obviously. See, in any topic, we are having some subtopics. So this is the basic question. Or you can say primary level question in temperature stresses. Even though it is not completed to you, here, I'll explain you the required things. Temperature stresses. So the main basic concept that is required to solve this question or to enter into the temperature stresses concept, the basic thing that is required is, as long as there is free expansion or contraction, as long as there is free expansion or contraction, there are no thermal stresses developed. That is a simple concept required. As long as there is free expansion or contraction. See, at this time, this seems to be very easy to you or simple to you. You may think that why I am repeating again and again. But without that, you can't solve this question. That is what application means. How simple it is, you say. As long as free expansion or contraction is permitted, no stresses. What does it mean? If those free expansion and contractions are restricted, then obviously thermal stresses will develop. This is the concept behind it. Now solve it. Then solve it. As I told you, this is the concept behind it. Then please try to solve it. Okay. Okay. So just think over it. See, here it may not be completed, but I think most of you are having some knowledge about stress, strain, and elastic constant relations. I think you're having some knowledge. So just give a try to it. Just try it. I'll explain, no worry, but just give a try to it. Think. Once you think, please. Online students as well, you please try it. I'll explain, don't worry. So have you gone through the question? See then how to solve this question. Actually, in these two questions are there. Okay, so first let me explain you the given informations. So see here, a copper rod of cross-sectional area cross-sectional area 305 millimeter square. Okay, connects two parallel walls at a distance of 5 meters apart. It means these are the two walls like this. This is one wall. This is one more wall. Now here the copper rod this is the copper rod, right? What is the distance here? 5 meter. Okay, these are the two parallel walls and the copper rod is kept in between. Right, the distance between those walls is 5 meter. Now, during this connection or fitting, this copper rod has heated to the 80 degrees centigrade. Okay, during the connection. Now, that is what here given. When the rod is heated to 80 degrees centigrade, the nuts at the end gets heated up. Okay, heated up. That is up to 80 degrees centigrade. Now, calculate the pull exerted by the bar on cooling at atmospheric temperature at 20 degrees centigrade. It means that during the making of this assembly or fitting, temperature is 80 degree. Now after that temperature has brought down to, it means it is heating or cooling. It is cooling. First that you should understand. What it is? Cooling. So because of cooling, what will happen? Expansion or contraction? Contraction. Okay, because of cooling, contraction will happen, right? So, what is the formula for the free expansion? Do you know that? Exactly, alpha, or you can say L alpha delta T. Right, the thermal expansion or contraction formula, I think you might have studied it in 8th standard if I am not wrong. Okay, 8th or 9th standard. So, here it is a cooling, right? Here it is a cooling. So, cooling means it is contraction, that you should understand. Therefore, free contraction. Okay, free contraction. Let it be delta L. So, what is the free contraction formula? Delta L is equal to L alpha delta T. Isn't it? This is the free contraction formula. Now, you please substitute that. What is the length of the copper rod? 5 meter, right? Use calci, right? See here, as you are targeting the mains examination, calci should be with you. Okay, you should use calci. For objective, it is not allowed, but here calci is allowed. So use calci. What is the length here? So 5 into alpha. Alpha is how much given in the question? Please tell me. Just a second, let me see. Isn't it? 17.5 into 10 to the power minus 6 or 10 raised to minus 6. And what is the change in temperature? 60. 80 minus 20. 60. Correct. Yeah, tell me. One more thing. Tell me the answer. 10 raised to minus 3. After that, is there any missing? Is there anything missing? Units. You need to be careful with units as well. Here, what is that parameter having unit? Alpha. Is there any unit for it? Per degree Celsius. For this delta T temperature, having any unit? Degree. So that degree will cancel. So therefore, alpha delta T has no unit. Then which parameter is having unit? L. Now this L we have taken in which? Meter. Then finally we are going to get in meter. So convert it into millimeter or keep it in meter itself. Okay, keep it in meter itself. So tell me in meter. 5.25 into 10 to the power minus 3 meter. Everyone got the same? This much the free contraction that copper rod can exhibit. Okay, that copper rod can exhibit, but will it do so? See here at the ends, listen, see here. Here at the ends, there is a connection like this. So it can't move, isn't it? So at the end, the copper rod is tightly fixed. Okay, it is connected to that wall. Therefore, it can't move. Whether the expansion or contraction, it can't do it. Okay, it is not possible. Therefore, but if it is not restricted, okay, if it is not restricted, then how much the free contraction this particular copper can exhibit? This much. So this is restricted. Corresponding to this stress will develop or not? So a simple concept of stress. So tell me the Hooke's law. Hooke's law. See, here I am not only solving the question as the strength of materials is not completed, just I am briefly revising those concepts also, required concepts also. But in examination, no need to write Hooke's law and all the things. So tell me Hooke's law, stress is equal to Young's modulus into strain. Now what is strain? Strain is nothing but change in dimension by original dimension. Okay, this is what? Okay, this is what? So now in the question, once you please see whether this is given or not. E is not given, but what are the informations that are given in the question? Once see. What are the information that are given in the question? Of course, alpha we have made use, right? See, you need to write given also, given information. So, alpha we have made use. Now, Poisson's ratio is given, and modulus of rigidity means what it is? G. Now, is there any relation between G and E? E is equal to. With this we can calculate it. It means see, straight away there will be no information in examination. That is why I told you. Multiple formulas are required to solve any question. Not a straight away single formula. Multiple formulas are required to solve a question. Now tell me the E value. How much? 10 raised to so 10800 units. I want units. Units. It is 10800 or something else. 10800, right. 000, yeah, that is what I am saying. Why? Because generally E is greater than G, right? So then what is the unit? MPa. Newton per mm square is nothing but megapascal. Right, it is a megapascal. So all these things are the most fundamental parameters you should remember. Okay, all these are the most fundamental you should remember. Right, this is E. Okay, this is E. So we know that stress is equal to how much the stress developed is equal to, as per Hooke's law. So stress developed is equal to E into delta L by L. So this is the most fundamental Hooke's law formula. Now how much the delta L is there? This one. L is known to us. E we have calculated. Now find the stress. Tell me the stress, how much it is? Correct. Not 11 point, some calculation error. You please check it. Exactly. How much it is? 1. See, everyone, please use calci. Without calci, you can't get it. So tell me the answer. See, everything is there here. Let me write 108,000 into 5.25 into by 5. Come on, tell me. Use calci. I know using calci will also give some wrong calculations. I know that. That is why I told you in the beginning itself. If your final answer is wrong, then full marks are not going to cut. But definitely there will be a deduction. How much? 113.4 units. Please tell me with units. Newton per mm square, or you can say. But what is asked in the question? Once you please see the question. He is asking the pull. Pull means force is asking. Now you got the stress. Then what is the pull? Force formula. stress into area. See, it covers all the concepts, first topic concepts of strength of materials, isn't it? Even though it is related to, temperature stresses, but will it covering all the topics in the first unit or not? All the formulas and concepts of first unit of strength of materials. This is how the question is going to be. That is why I have chosen this question. It is covering temperature stresses concept as well, and basic Hooke's law, stress strain relation, and stress and force relation. Everything it is covering. That is why I have given this question. So tell me, what is the stress here? Area is how much? Tell me. See, beginning you need to write given also, right? Beginning you need to write the given also. Tell me how much? 34 point. It means kilonewton. See, be professional. 10 cube means generally we take it as kilo. 10 raised to 6 means we take it as mega. 10 raised to 9 means we take it as giga. Right, at least you should remember up to that. Okay. How much it is? 34.5 kilo. See, don't tell me the value. Tell me the value along with unit. Okay, tell me the value along with unit. Suppose two persons are having same name. Then obviously we address them with their surname. The same here. Simply 34.587 means what it is. Right, so you should address it with unit. Okay, you should address it with unit. Very important. Units will also have the marks. That is very crucial. Even though it is a fundamental and easy, but it will have marks. Clear all of you? Tell me, any difficulty is there here? But application, see application. This is what I told you. Theory, formula and application. What is the theory required to solve this question? If there is free expansion and contraction, there are no thermal stresses. But if once those expansions and contractions are restricted, then stresses will develop. That is what we have calculated. And based on that stress, we have calculated even pull also. So this much pull that copper, okay, this much pull that copper rod is exerting on those parallel walls. So online students, is clear? Of course, here also. Yeah, Neha and Om Shivanand. Yeah, correct. Good. They also given their answers. So clear all of you? Online students, please respond. Now see the next part. Based on this concept, now can you solve the next part? I'll expect from you. Okay, I'll give you some 2 to 3 minutes of time. Why? Because in examination you don't have whole day to solve the question, right? Come on, do that question. I'll give you some 2 to 3 minutes of time. As I explained you the first part. Now come on, do the second part in this question. So this is next level, further level. Okay, this is a further level, further concept. Come on, do it. Online students, come on, start doing the second part. Second part in this question. See, if you have any doubt, please ask me. Don't hesitate to ask the doubts. Whatever the doubt may be, you please ask it. Don't think that my doubt is silly and don't think that my doubt is intellectual. Doubt has no such classification. Doubt is a doubt that should be rectified. So please don't feel or hesitate to ask the doubt. Please ask the doubts. Whatever the doubts you are having, you please ask in the class itself. In examination, no one will answer you. Because while we are attempting the questions, so many doubts will arise. At that time, no one is there to answer you. But here in the class, I am here or any other concerned faculty will be there. You please be clear with all the doubts. Doubt should arise. Okay, usually doubts will arise. It should arise. And those doubts should be rectified. Then only you will get conceptual clarity. Okay, then only you will get conceptual clarity. Therefore, whatever the doubts you are having, any one of you, please feel free to ask. Okay, please feel free to ask the doubts. Clear, all of you? Yeah, come on, please do it fast. With this, I'll close the today's session. See, where you got stuck, you please tell to me. Where you got stuck, you please tell to me. Or you please ask me the doubt. As I explained in the first part. So this part is almost similar to the first part, but is extension. Okay, next level you can say. Same formula. Huh? Use of mu. So already we have made use of, as I told. See, I am telling you, second part is, you can say, extension to the first part. So whatever you have done in first part, that you need to make use. Along with that, some additional addition is there. Correct. Good. Correct. His answer is correct. Good. What about others? So by solving the first part, easily you are able to solve the second part, provided you are having that clarity. This is what application means. Nothing new. So how much it is? 18 point. Correct. See, tell me with unit. So please tell me with unit. Okay, try to make a habit of it. Okay, correct. What about others? So do you face any difficulty in solving that? See, don't hesitate. Whatever you feel, you please express it genuinely. Don't hide anything related to the subject. Others also. I want answer from others also. See, tomorrow onwards, everyone should carry Calci with you. And whatever the subjects that are completed, you please start solving conventional questions. As I told you, you should feel responsible by yourself. Even though you might have joined the coaching, but this is not everything. Okay, this is not everything. Finally, you need to reach to your goal. So start solving the conventional questions. Even we are going to provide it, no worry. But before that also, please start it. Almost 10 minutes, 5 to 10 minutes. So online students, any one of you got the answer? Do it fast. Tell me with unit. Correct. Good. So what about others? See, same theory and formula, nothing new. Same theory and formula, but application. Application. What is the answer? So last. So if you have any doubts, as I am asking you, I have given the time, you please ask now itself. Even though it is not completed, but it is a fundamental question based on strength of materials. That is why I have given question in first unit of strength of materials, not the other units, or not on principal stresses. For that, for sure, you require explanation or completion of the subject. But for this, not required. Simple stress strain formula, Hooke's law formula, and stress and force formula. Simple formulas. That is why I have given this question. So see here, see what is the second question, all of you? See, only two online, no one in online. What about online students? Do you got the answer? Okay, listen, concentrate. So what is said in this second part? If ends yield by 2.5 mm, ends means these two walls, right? Ends means these two walls. Yielded means they have expanded or contracted, whatever it may be. But here, as per the question, it should be contraction. Okay, as per the question, it should be contraction. So now if ends, why? Because of fall in temperature, this copper rod tends to contract. Now in that process, this particular copper rod is going to exert a pull on the walls, right? Pull on the walls. If those walls are able to withstand that particular pull, then they will not move or they will not yield, isn't it? If the walls are having enough strength, okay, if walls are having strong enough or having enough strength, they will not move. Move means they will not yield. That is the first case. Now what is the second case? Now walls has yielded 2.5 mm. It means now this is the new position of the wall. Now this is the new position of the wall. You please observe here. So on both sides the yield will be there. What is the total? Total yield 2.5 mm. Now on both sides how much it should be? Half of, right? That is 2.5 by 2. How much it is? 1 point. Here. Isn't it? Isn't it? Now what is the net contraction? So what is the total contraction? 5.25 mm. What is the total contraction? 5.25 mm. So that is the contraction the copper rod can exhibit. In that process, that copper rod has pulled the walls along with it. How much it has pulled? 2.5 mm. Now what is the net contraction? This 5.25 minus 2.5, isn't it? That's it. So you tell me, any new formula is there? Application. Any new formula is there? No, application. That is why I told you, application is the most crucial part. Right? See. So now net contraction. So net contraction, let it be delta L1. So net contraction delta L1 is equal to delta L initial minus yield of the supports. Yield. Okay, yield of that ends, or you can say supports. Then what is the delta L we have calculated in the first question? How much it is? 5.25 mm. Now here I am taking in mm, not in meter. Okay, 5.25 mm minus 2.5. How much it is? Please tell me. 2.75. Okay. Then same formula, stress. What is the stress formula? Stress is equal to E into delta L1. This time it is delta L1. Okay, net we need to take by L. That is 108,000 into 2.75 by, this is in mm. Now you please take length in mm, or in similar way also you can do 10 to the power minus 3, 5. How much the stress? Please tell me the stress. Stress, please tell me the stress. How much? 59.4 Newton per mm square. Now pull. Let it be sigma 1. Okay, sigma 1 let it be. So sigma 1 into A, that is 59.4 into what is the area? 305. Yeah, tell me the answer. 18.117 kilonewton. That's it. All of you, please tell me any new formula had I used? Any new concept had I used? Just application. This is what application is all about. And that too, this is the most fundamental question we can expect from first unit of strength of materials. So this is how we are going to do that question practice session. It means with this one question, we have revised Hooke's law, that is stress strain relation, and relation between force and stress, that is axial stresses, and then temperature stresses. In temperature stresses, we have done both the cases, support yielding and no yield of the support. That's it. Clear all of you? This is what required. So merely studying will not give you the marks or result. Of course, you need to study. As I told you, that is the first step, learning the theory, attending the classes. But after that, there are 9 steps. The total 9 steps is practice, practice, practice. That's it. Clear all of you? So do you find this session as a fruitful? All of you? Tell me yes or no. I want a loud response from you. Yes or no? Yes. So this is all about answer writing. Okay, this is all about answer writing. So with this, I am going to conclude the session. But before that, I want to know any doubts from your end. So any doubts from your end? Online as well. So online students, is it clear for you? And offline also, if you have any doubts, you can please ask. Or else this is the end for this session. How? For numerical, nothing, no conclusion. Answer is the conclusion. Answer, nothing. Those extras are not required, those decorations, right? Answer itself is the conclusion. Yes, see, you are not supposed to decorate the papers. Answer sheet, final answer. Why? Because see, we don't have that time in final examination. Finally getting the answer and we need to proceed to the next question. Fatafat we need to do it. We don't have that much of time. No such conclusion. Answer itself. If you want, you just highlight F is equal to 18.117 kilonewton and do like this. So answer itself is the conclusion. Right. And even in theoretical questions also, just a second. Even in theoretical question also, conclusion is not for all the questions. That is a framework. That should not be followed for all questions. Okay. It depends. It depends. Right. Is there any? What's limit in sense? MPSC, as it is not conducted right from 2011, but you see in UPSC, for each question they will give the space. So limit is there. That is why practice matters. So they may give 1 page or 1.5 page or 2 pages. So accordingly you need to plan. That is why I am telling you 5 marks question, 20 marks question. If it is a 5 marks question, accordingly you need to answer.
For 5, how many pages?
That we can't tell, but maybe 1 page or 1.5 page, it depends. 1 page more mainly. If it is 20 marks, then 2 pages. So online seems to be no doubt. So I'm going to end the session.